So today I'm going to be doing number 15. A 2-gram bullet leaves the barrel of a gun at a speed of 300 meters per second. We're going to find its kinetic energy, and we're going to find the average force exerted by the expanding gases on the bullet as it moves the length of the 50 centimeter long barrel. So this is my diagram. Using our givens, we can discover that this is 50 centimeters long, but we want to convert this to meters so we can use it in our formulas. And we also know that the bullet's 2 grams, but we want to convert that to kilograms so we can use it in our formula. And we also know that the final velocity is 300 meters per second. So the first part of this problem is that we want to find the kinetic energy. So we're going to use this formula, which is kinetic energy equals half mv squared. Take note that the v squared is actually vf squared minus vi squared. So we're going to expand it to this. So the initial velocity is 0 because the bullet is starting at rest, and so we're going to just use this part of the equation, and when we plug in the values for that, we get this, and when we calculate this, we get 90 joules as the kinetic energy. Alright, now we're on part 2 of the problem, which is to find the average force. So we're going to use the formula force equals mass times acceleration. So we already know that the bullet's mass is 0.002 kilograms. We don't know its acceleration. So we're going to solve for acceleration using a kinematic. So the values we know are the initial velocity is 0 meters per second, the final velocity is 300 meters per second, and the delta x, or displacement, is 0.5 meters. And we get these values from our diagram. So we're going to use the kinematic vf squared equals vi squared plus 2a delta x. Now, don't forget that the initial velocity is 0 because we started at rest. And so we're going to plug in the other values because we want to solve for a. When we solve for a, we get 90,000 meters per second squared. So now that we have a, we want to put it back into the force equals mass times acceleration formula. And we're going to get 0.002 kilograms times 90,000 meters per second squared, which is 180 newtons.